The topic of this video is how to sketch a rational function. I'm going to mention 6 usual steps that you might use in doing so. Now, an example of a rational function, here y equals fraction, numerator negative 3x minus 12 over denominator 2x minus 2. This is classified as a rational function because the numerator is a polynomial and the denominator is a polynomial. In this case, each of the two polynomials is a binomial of degree 1. The highest power is x to the first in the numerator, and the highest power of x is x to the first in the denominator. Now, it's a great idea in going through these 6 steps to initially factor the numerator and denominator as much as you can. In this case, there's a negative 3, which is a greatest common factor of the two terms in the numerator, leaving you, when you factor, with negative 3 times parentheses x plus 4. And the greatest common factor of the denominator is 2, leaving you with x minus 1 as a factor in the denominator. All right, now on to the 6 steps. The probably easiest step of the 6 is to figure out the y-intercept in the function. And you might recall that you can find y-intercepts by setting x equal to 0 in the equation. Now, if we did that, it would leave us with negative 3 times 0 minus 12 for numerator, and 2 times 0 minus 2 for denominator, negative 12 over negative 2, which is just 6. And I'm going to color code this. I'm going to put that feature in a color blue, and then move on to a second feature, and I'm going to color code that and put that in red. Now, immediately, the y-intercept occurring at y equals 6, we can go over to the graph and throw that in. Now let's move on into the second feature, which is called horizontal asymptote. Now, not every rational function will have a horizontal asymptote, but this particular example does have a horizontal asymptote. I'm going to show you how to figure out what that asymptote is. What you do is you take a ratio, the HOT ratio. HOT meaning highest order term. Now, in this particular function, the numerator has as a highest order term negative 3x. And the denominator has as a highest order term 2x. When you simplify this ratio, you get y equals, canceling the x's, negative 3 over 2. And that is the equation of the horizontal asymptote. So I'm going to go back over to the sketch, throw in a horizontal asymptote at y equal negative 1.5. I've just put that in the wrong position. I'm going to fix it. Y equals negative 1.5. That's the same as negative 3/2. Now let's move to the factored form of the equation for the next 2 features. The first of those, feature number 3, is x-intercept. Now you find x-intercepts by setting y equal to 0. Now if we do that, we get an equation 0 equals negative 3 times x plus 4 over 2 times x minus 1. Now the only way that this right hand side, the fraction, can equal 0 is if x is equal to negative 4. And you can tell that that'll make it 0 by reference back to this factor. If you put negative 4 in for x, substitute negative 4 for x right there, you end up with negative 3 times the quantity 0. Yep, that value, x equals negative 4, will make the whole quantity 0. And let's move on to another feature. Put this in green. Feature number 4 is called a vertical asymptote. And this particular function has a vertical asymptote, as will any rational function that has part of its denominator which can potentially be 0. In this case, the factor x minus 1. X minus 1 will equal 0 if x equals 1. Now, in some sense, we're actually saying that in this function, x cannot equal 1. The reason being, if x was made 1 here, 1 minus 1, 0, 2 times 0 is 0, you'd be attempting to divide by 0 in this function, and that's not allowed. So let's go ahead and in green put in a vertical asymptote at x equal to 1. I'm going to change the tool there to a straight line drawing mechanism. At x equals 1, we would have a vertical asymptote. And I've just noticed, let's go back and in pink or magenta, let's put that x-intercept, which we said was occurring at x equals negative 4. Let's put that in as well. We have pretty many features. Let's go for another. I'm going to call this feature, the fifth one, extra points. And the extra point that I'm going to come up with in this problem is just to the right of this vertical green line. I'm going to create an extra point for this function by using x equals 2 in the original equation. So y equal negative 3 times 2 minus 12 over 2 times 2 minus 2 equals negative 18 over 2 equals negative 9. So there will be an extra point to place into our graph at 2 comma negative 9. I'm going to go ahead and put that in right there. Now, there is a sixth potential feature within a rational function, and that is often referred to as a hole. And in this particular problem, I'm just going to tell you without explaining it, there is no hole in this graph. We're going to come to that in the next example. Now let's try to put all of this together. I'm going to draw the sketch of this graph in black. Let's start way off to the left at the horizontal asymptote, the red line, and remember that we should not have the graph touch that red line. It'll curve upward a little bit through the x-intercept at negative 4, curve up further, hit the y-intercept at 6, and then go virtually straight up, but never quite touching the vertical asymptote at x equal to 1. Now the value of this extra point at 2 comma negative 9, it helps us to decide how to draw the rest of the function. Now notice I've started very far down, near the vertical asymptote, come upward through the point 2 comma negative 9, and then curved off to the right and came out almost paralleling the horizontal asymptote. So this is the complete sketch for that function. Let's use the graphing calculator to verify that the sketch we've come up with by hand agrees with what we came up with on the calculator. So go to y equals, so you're in function mode, and let's put this original form of the equation in, y equals, we're going to have to start off that numerator of the fraction with a parentheses, negative 3x minus 12, end parentheses, divided by new parentheses 2x minus 2. To set up a nice window for viewing that matches our sketch, in other words, negative 10 to 10 on the x and negative 10 to 10 on the y, we can always choose zoom standard. That's zoom option 6. Here comes the sketch. Let's see how it matches ours. Looks very similar. Let's throw in one more thing. Let's go down to y2 and let's throw in negative 3 over 2 as y2. That should put in a horizontal line, y equals negative 3 over 2. Let's graph that. Oh yeah, perfectly that matches the horizontal asymptote. So it looks like we've verified the sketch done by hand.